Hello everybody, thank you for joining today. My name is Onam and today we're going to be talking about seismic waves. So some of our learning objectives include to describe P waves and S waves, so primary waves and secondary waves. How can we use these P and S waves to build up a picture of the Earth? Now, let's start having a look at P waves and S waves. Now, P and S waves both belong to a category called seismic waves. So let's write that down. Seismic wave. Seismic wave. Now, seismic waves are waves that travel throughout Earth as a result of earthquakes. Now, all an earthquake is when the two plates on Earth, right, that all of our countries rest upon, when they collide and they rub against each other, when that slip happens, an earthquake occurs. And so, when an earthquake occurs, two types of waves are given off: P waves and S waves. Now, P waves are longitudinal waves. Now, if we remember our definition for longitudinal, that's when particles oscillate parallel to direction of energy transfer. And so our secondary waves are transverse waves. And if we remember our definition for transverse waves, that's when the particles oscillate 90 degrees or perpendicular to direction of energy transfer. Now, how can you remember that S waves are transverse and P waves are longitudinal? Well, the way I always think about it is S waves or secondary waves have an S in them, and transverse also has an S in them. So I think SS, so secondary transverse. Now, what are another really cool fact about secondary waves that you need to remember is that S waves cannot travel through water. Now, this is actually a very, very key fact, and this is what allows us to build up a picture of the interior of the Earth just by using P and S waves. Now, when an earthquake happens, so let's take our globe here, right? Again, I'm not going to win our awards, but it's physics. Okay, let's take our globe there. If an earthquake occurs on this side of the Earth, right? I'm just going to draw like that just to signify that an earthquake is happening. P waves can also be detected on the other side of the Earth. So let's write here, P waves detected. Now, what we also know that S waves are not detected on the other side of the Earth, or they're extremely faint. That tells us that throughout the center of the Earth there is some form of liquid, because we know that S waves cannot travel through water or liquids. So we can tell that there is a liquid center of our Earth. Also, the P waves are also refracted, which means that they slow down and change direction. So we can see that we detect P waves at different corners of the Earth, and this now tells us that there are different mediums present inside the Earth, and that lines up with the evidence that we later discover through, let's say, excavation. So, because we know that the Earth has a dense liquid core, and then it has a less denser liquid surrounding that. Then it has layers and layers and layers of rock, which are different types of rock. So the crust is made out of one, the upper mantle, etc., etc. And so all of this data is found from P waves and S waves. So now you understand seismic waves. Now let's have a look at our worked example. Pause the video and give it a go yourself first, and then I'll run through it. Okay, as always, we're going to highlight all of our keywords. So the diagram shows the path of a P wave. Straight away, that's something we need to highlight, that this is a P wave. The P wave travels from collision X through the Earth to another point A. Okay, explain why the path of the P wave is not a straight line. Okay, so it's talking about why the P wave is curved. Now, curved P wave. P wave is a longitudinal wave, And what property of a wave causes it to change direction? Now, that property is called refraction, okay? So here we have the P wave refracts through the Earth. Now, why does it refract? Remember, refraction can only happen when when the medium changes that the wave is traveling through. So, the P wave refracts through the Earth due to a change in medium, and we can actually go a little bit further to make sure we secure this mark perfectly and say, in brackets, changing rock density. Because remember, as I said in earlier on in the video, that as you go through the Earth, the density of the rock changes, the composition of the Earth changes, so your P wave starts to refract and it starts to curve. So there you go, straight away we have 2 marks right there. Now the next question, again, let's highlight all the keywords. Explain why there are regions on the Earth's surface where S waves from the collision at X cannot be detected. Okay, you can add to the diagram to help your answer. I don't need to add to the diagram, but let's do this anyway. Explain why there are so one property of S waves is that they cannot travel through liquids. Okay, you need to remember this, and we know that at least part of the Earth's core is liquid. So when the S wave gets to the Earth's core, it will just stop right there. It will be absorbed there, so you won't detect it on the other side of the Earth. So let's put that into words. So S waves cannot travel through liquids. Part of the Earth's core is liquid. Therefore, for the S wave cannot pass through. I'm running out of space. Should have done it higher. The center. And be detected on the other side. That's the little bit that I don't have space to write, but you can write it yourself. So that will be 3 marks right there.